Hello. You might be wondering, why are we in the kitchen today?
Well, it's to explain why when you have water and you add a little bit of salt, it actually makes it harder to boil. Let's learn why. Imagine water molecules are excited kids inside a trampoline park, jumping up and trying to escape over the walls into the air. When water boils, it just means that those kids finally have enough energy to finally, jump out and go into the air and become what we know as steam. What happens when we add salt, like I just did right there? Salt breaks apart in the water into positive and negative ions and acts like a bunch of strict camp counselors. These salt counselors grab onto the water kids, holding them down. Because the salt is holding on to them, the water kids have to jump much, much harder to escape. To make them jump harder, you have to turn up the heat. The extra heat is why the boiling point goes up. Now let's step it up to college chemistry level. The phenomenon is a colligative property. Naming it depends strictly on the number of solute particles in the solution, not their chemical identity. This specific effect is called boiling point elevation. To understand why it happens, we need to look at vapor pressure and entropy. Liquid water is in a constant state of dynamic equilibrium with this vapor. Boiling occurs when the vapor pressure of the liquid equals the atmospheric pressure pushing down on it. When you dissolve table salt, sodium chloride, into water, it dissociates completely into sodium and chloride ions, what I mentioned earlier, the positive and negative ions. This introduces two major changes. One, there are stronger intermolecular attractions, right? Water molecules are highly polar. They form strong ion dipole bonds with the newly dissolved sodium and chloride ions. And these attractions are obviously much stronger than just the hydrogen bonds that were there before, making it harder for water to transition from a liquid to a gas. Liquid water with dissolved ions is also much more disordered than pure water, meaning it has higher entropy. Nature prefers higher entropy, right? It's like the classic excuse as a kid, sorry, my room is messy, but that's just entropy, right, Mom? But because the liquid phase is now extra stable and more disordered, the system resists changing into a gas, which would require much more energy. And because of these two factors, the vapor pressure of the solution drops at any given temperature. To make the vapor pressure rise back up and match the atmospheric pressure, you must inject more thermal energy. And we can calculate it by using formulas and whatnot, but you're not in school. I'm not in class right now. So we don't need to worry about formulas. All we have to remember is that those ions are the strict camp counselors, and they're not letting the water kids jump out of the solution anymore. Let's go back to the kitchen. And that's why to boil the same amount of water, right, we have to just turn up the heat.